Hello student, I am Ekta. Before, we could learn about compound variation. Let's recall the concept of direct and inverse proportions. If two quantities are such that an increase or decrease in one quantity makes a corresponding increase or decrease, same effect in the other quantity, then they are said to be in direct proportion. In other words, x and y are said to vary directly if y is equal to kx always, where k is called the proportionality constant and k less than 0, assuming that y depends on x and so k is equal to y by x. Few more examples of direct proportion. Number 1, distance time under constant speed. If the distance increases, then the time taken to reach that distance will also increase and vice versa. Number 2, purchase spending. If the purchase of utilities for a family during the festival time increases, then the spending limit also increases and vice versa. Number 3, work time earnings. If the number of hours worked is less, then the pay earned will also be less and vice versa. Similarly, if two quantities are such that an increase or decrease in one quantity makes a corresponding decrease or increase opposite effect in the other quantity, then they are said to be in inverse indirect proportion or said to vary inversely. In other words, x and y are said to vary inversely if xy is equal to k always, where k is called the proportionality constant and k less than 0. Few more examples of inverse proportion. Number 1, price consumption. If the price of consumable products increases, then naturally its consumption will decrease and vice versa. Number 2, workers' time. If more workers are employed to complete a work, then the time taken to complete the work will be less and vice versa. Number 3, speed time, fixed distance. If we travel with less speed, then the time taken to cover a given distance will be more and vice versa. After the completion of this lesson, you will be able to know learning objectives. Understand the concept of compound proportion. Different types to solve compound proportion. Solve application problems using a compound proportion. Keywords from this lesson: ratio, proportion, direct proportion, inverse proportion, speed, time, distance, Compound. Compound variation. Let's now see what a compound variation is. There will be problems which may involve a chain of two or more variation in them. This is called compound variation. The different possibilities of the two variations are direct-direct, direct-inverse, inverse-direct, inverse-inverse. Let's now solve a few problems on compound variation. Here we compare the known quantity with the unknown x. There are few methods in practice by which problems on compound variations are solved. Number 1, proportion method. In this method, we shall compare the given data and find whether they are in direct or inverse proportion. By finding the proportion, we can use the fact that the product of the extremes is equal to the product of the means and get the value of the unknown x. Number 2, multiplicative factor method. Illustration. Here the unknown x is in men and so it is compared to the known, namely hours and days. If men and hours are in direct proportion d, then take the multiplying factor as d by c, take the reciprocal. Also, if men and days are in inverse proportion I, then take the multiplying factor as e by f, no change. Thus, we can find the unknown x in men as x is equal to a into d by c into e by f. Number 3, formula method. Identify the data from the given statement as person P, days D, hours H and work W and use the formula. P1 into D1 into H1 by W1 is equal to P2 into D2 into H2 by W2. Where the suffix 1 contains the complete data from the first statement of the given problem and the suffix 2 contains the unknown data to be found out in the second statement of the problem. That is, this formula says P1 men doing, W1 units of work in, D1 days working, H1 hours per day in the same as P2 men doing, W2 units of work in D2 days working, H2 hours per day. Identifying the work W1 and W2 correctly is more important in these problems. This method will be easy for finding the unknown x quickly. Direct variation. Example. If a company pays rupees 6 lakh for 15 workers for 20 days, how much would it need to pay for 5 workers for 12 days? Solution. Multiplicative factor method. Here, the unknown is the pay x. It is to be compared with the workers and the days. Step 1. Here, less days means less pay. So, it is in direct proportion. The multiplying factor is 12 by 20. Take the reciprocal. Step 2. Also, less worker means less pay. So, it is in direct proportion again. The multiplying factor is 5 by 15. Take the reciprocal. Step 3. Therefore, x is equal to 6 into 12 by 20 into 5 by 15 is equal to rupees 1.2 lakh. Formula method. Here, P1 is equal to 15, D1 is equal to 20 and W1 is equal to 6. Also, P2 is equal to 5, D2 is equal to 12 and W2 is equal to X. Using the formula, P1 into D1 by W1 is equal to P2 into D2 by W2 is equal to 15 into 20 by 6 is equal to 5 into 12 by X. Is equal to x is equal to 5 into 12 into 6 by 15 into 20. Inverse direct variation. Example. If 81 student can do a painting on a wall of length 448 m in 56 days, then how many students can do the painting on a similar type of wall of length 160 m in 27 days? Solution. Multiplicative factor method. Here, the unknown is the student x. It is to be compared with the days and the length of the wall. Step 1. Here, less days means more student. So, it is in inverse proportion. The multiplying factor is 56 by 27. Step 2. Also, less length means less student. So, it is in direct proportion. The multiplying factor is 160 by 448. Step 3. Therefore, x is equal to 81 into 56 by 27 into 160 by 448. X is equal to 60 students. Formula method. Here, P1 is equal to 81, D1 is equal to 56 and W1 is equal to 448 and P2 is equal to X, D2 is equal to 27 and W2 is equal to 160. Using the formula P1 into D1 by W1 is equal to P2 into D2 by W2 is equal to 81 into 56 by 448 is equal to X into 27 by 160. X is equal to 81 into 56 into 160 by 448 into 27. X is equal to 60 students. Inverse variation. Example, if 48 men working 7 hours a day can do work in 24 days, then in how many days will 28 men working 8 hours a day can complete the same work? Solution. Multiplicative factor method. Here, the unknown is the days x. It is to be compared with the men and the hours. Step 1. Here less men mean more days, so it is in inverse proportion. The multiplying factor is 48 by 28. Step 2. Also, more hours mean less days, so it is in inverse proportion again. The multiplying factor is 7 by 8. Step 3. Therefore, x is equal to 24 into 48 by 28 into 7 by 8 is equal to 36 days. Formula method. Here P1 is equal to 48, D1 is equal to 24, H1 is equal to 7 and W1 is equal to 1. Why? P2 is equal to 28, D2 is equal to x, H2 is equal to 8 and W2 is equal to 1. Why? Using the formula P1 into D1 into H1 by W1 is equal to P2 into D2 into H2 by W2. Is equal to 48 into 24 into 7 by 1 is equal to 28 into x into 8 by 1. Therefore, x is equal to 48 into 24 into 7 by 28 into 8 is equal to 36 days. Points to be remembered. There will be problems which involve a chain of two or more variation in them. This is called compound variation. By finding the proportion, we can use the fact that the product of the extremes is equal to the product of the means to find the unknown x in the problem. By using the formula P1 into D1 into H1 by W1 is equal to P2 into D2 into H2 by W2, we can find the unknown x. If two persons X and Y can complete some work individually in A and B days, their 1 day's work will be 1 by A and 1 by B respectively, and X and Y together can complete the work in AB by A plus B days. Thanks for watching.